We will begin the presentation of CSEC Multiple Choice Practice Paper 3 with Part A. Part A is comprised of the first 15 problems. This problem requires that we develop an arithmetic expression for the simple interest given the information that we have right here. We will use the regular formula for calculating the simple interest. Simple interest is equal to principal multiplied by rate multiplied by time. This may come as a surprise to some candidates who are accustomed to saying that the simple interest is equal to principal multiplied by rate multiplied by time over 100. The rate is a percentage, a fraction with 100 as its denominator. Dividing by 100 is therefore a redundancy. As long as the rate is included, dividing by 100 is mandatory. Including 100 in the formula is just a bad habit that we have developed over the years. So the principal is $500. The time is 4 years and the rate is 6%. 6% means 6 over 100 or 6 divided by 100. There we have it. 504 may be treated as fractions whose denominators are equal to 1. So we are going to write these as fractions also. Writing these as fractions, we may write those whole numbers as fractions whose denominators are equal to 1. Complying with the forms of the options, we may leave the product of the numerator as is, and in the denominator, we make use of the fact that any number multiplied by itself is equal to 1. So we will have 500 multiplied by 6 multiplied by 4 for the numerator, and in the denominator we will say any number multiplied by 1 is equal to itself. So we will say 1 multiplied by 100 multiplied by 1, and that will be equal to 100. The correct answer is option D. There we have an algebraic expression, and of course by the physical appearance of these options, we imagine that there is some simplification process that we may carry out on those terms. We have an algebraic expression. It is representing a sum. All we need to do is combine the like terms. Although there are negative terms, the expression is still a sum. Subtraction is just a matter of adding in the opposite direction, and that is what we learn in directed numbers. So we are still going to call that expression a sum. Let us combine the like terms, if any. So we have like terms 5x, negative 3x. We put those together. 5x minus 3x is equal to 2x. What about this one? Negative 2y plus 2y is equal to 0. We do not have to include that 0. When two numbers are added and the result is equal to 0, they are called additive inverses. This is because they have a cancelling effect on each other. So the negative 2y and 2y together will add to give 0. They are additive inverses. The correct answer is option A. When 0 is added to a number or expression, the value is not affected by it. We may therefore say that any number added to 0 is equal to itself. For this reason, 0 is called the additive identity. 1 is called the multiplicative identity because when a number is multiplied by 1, the result is identically equal to that same number. What is the value of 2x squared when x is equal to negative 3? 2x squared when x is equal to negative 3. There we have our 2x squared. In finding the value when x is equal to negative 3, we need to substitute negative 3 in the place of x. That's all we need to do. Where we see x, we put a negative 3. So we have 2 times negative 3 squared. When we square negative 3, the result is positive 9. When numbers or expressions follow each other, like we have right there, not separated by a sign, the sign that we assume is multiplication. So 2 multiplied by 9 is equal to 18. And the final result is 18. The correct answer is option C. It is important to note that whether we square a positive or a negative number, the answer is always positive. Also, one problem that candidates may encounter is that while squaring, we neglect to have the sign inside of the brackets. So instead of finding the square of negative 3, we do negative the square of 3, which turns out to be negative. So that's a problem that we need to resolve. We need to understand that when we square a negative, the answer is different from the negative of a square. And I'm sure that within Richard James Mathematics Resources, we will have an highlight and further explanation of such a principle. If a car runs 160 kilometers on 16 liters of gasoline, then with 40 liters it should run, and that is a proportionality problem. We may solve this problem mentally, no doubt. 16 liters give 160 kilometers. 1 liter will give 160 divided by 16, and that will be 10 kilometers. 40 liters will give 40 multiplied by what? The distance that will be given by 1 liter. So if 1 liter will take us 10 kilometers, then 40 liters will take us 40 times 10, which is equal to 400 kilometers. So the correct answer is option C. And in an examination, we are not necessarily required, but we should be capable of making some calculations, especially some that are as simple as that one. We should be able to make that mentally. However, we will make use of a simple argument that is based on proportions to solve the problem. We will move from 16 liters to 40 liters by way of 1 liter or via 1 liter. So we have 160 kilometers on 16 liters, and we want how far it will go on 40 liters. So we move from 16 liters to 1 liter, then to 40 liters, and that is generally a recommended process at all levels. So we have 16 liters will take us 160 kilometers. The distance equivalent to 1 liter may be found by dividing both sides by 16. So if we divide by 16 here, we divide by 16 here, and see what happens. 16 divided by 16 is 1, and 16 into 160 is 10. So we have 1 liter will take us 10 kilometers. We will now multiply both sides by 40 in order to determine the distance equivalent to 40 liters. So we will multiply by 40. So 1 multiplied by 40 will be 40. So we will have 40 liters here. By multiplying by 40 on the other side, we will conclude what distance that 40 liters will take us. So there we have it. Multiplying, we get, no doubt, 400 kilometers. The correct answer is option C, as we have calculated before. Taking on that same problem again. The problem may also be solved by using ratios. In this case, the ratios will be written as fractions with some order. The distance will be the numerator and the volume of gasoline will be the denominator. In both cases, the distances traveled and the volume of gasoline are in the same proportion. Therefore, the ratios and hence the fractions will be equal. So in our fractions, we will put distance over volume all the time. 160 kilometers is associated with 16 liters. Those will be in the first fraction. The distance that we do not know, we will call x. It is associated with 40 liters and will be in the second fraction. So we have the first fraction with the knowns and the second fraction with one unknown. And we write them with the distance in the numerator all the time and the volume in the denominator all the time. The equation may be transposed to give. When we transpose, we may have 16x is equal to 160 multiplied by 40. And we may continue to transpose that equation. We get 160 times 40 over 16. The fraction may be reduced by a common factor of 16. We are multiplying by 16 here, so we divide by 16 on the other side. That is what we have right here. Then we see a common factor of 16. 16 into 16 is 1. And 16 into 160 is 10. And we finish up by saying 40 multiplied by 10. And that gives us 400 kilometers. The correct answer is option C, as we have determined during the first take. The problem involves two vectors. How do we know that they are vectors? Because they are written with common letters that are underlined. Common letters underlined. If we were talking about regular matrices, we would have used a capital letter to represent each one. So the problem involves two vectors, but they are actually column matrices called column vectors. The laws that pertain to the addition of matrices will therefore apply. Two matrices may not be added or subtracted unless they are of the same order. That is, they must have the same number of rows and columns. So we have these two will have 2 rows, 1 column. 2 rows, 1 column. They are of the same order. We may subtract one from the other, or if that were the case or the requirement, we could have added them together also. They have the same number of rows and columns, which is the same order. We will therefore proceed to subtract corresponding elements. So we say 6 minus 3 is 3 and 6 minus 2 is 4. So we have 3, 4. The correct answer is option A. When adding matrices, that is, we will add them of the same order, corresponding elements are added, or in this particular case, subtracted. So that is the rule. We cannot add matrices unless they are of the same order. When they are of the same order, we add or we subtract corresponding elements. So with the one at the top, we subtract the one at the top, and so on. We need to find the value of 2 in the number for 125.3. And we are making use of place values. When reading the place value of a number, use the ones position as the central position of the number. So the ones position will be the central position. Immediately to the left we have the tens, and to the right we have the tenths. Next, on either side we have hundreds to the left and hundredths to the right. And we know what will follow. Thousands and thousandths are rightly placed on their respective sides. The number that we have may be similarly labeled with the appropriate digits and decimal places. Of course, this time we only have 4 digits, but we can label them appropriately, no doubt. The value of 2 is therefore 2 tens. This represents option C, 2 tens, as we have the labels right here. So we have ones here, tens, hundreds, and on the other side we just have tenths. So 2 tens. In a decimal number, the point is not the central position. The ones position is. So the central position is the ones position. The point is there to separate the whole number from the fraction. Everything that is inside of the brackets will be affected by the power of 3. Right? Every single thing. But how so? That is the power of 3 that will affect everything that we have inside of that bracket. According to the laws of indices, when we have a number with an index raised to another power, we multiply the indices. We have a number, or in this particular case a letter, with an index raised to another power, we multiply the indices. So we have x to the power of 2 multiplied by 3. By carrying out the multiplication process, the final answer may be written, just multiply 2 by 3, that's all. We have 6, x to the power of 6. The answer is option C. It is very difficult to see how someone could have chosen option A. Options B and D could have been chosen because of ignorance or a mental lapse. 2 plus 3 is equal to 5, and 2 to the power of 3 is equal to 8. So of course we can see that if candidates are not aware of the rules, or they have a lapse in concentration, they could have placed those values down. But option A is probably the one that is furthest away from being a distractor. Applying the rule appropriately will eliminate such maladies. Here we have a triangle, and we are told that AB is equal to 12 centimeters. AC is 13 centimeters, and BC is equal to 5 centimeters. We need to find the value of tan C. We have here that what? Tan C is equal to opposite over adjacent. And I will not take it for granted in this presentation that anyone knows what opposite is and what adjacent is. According to the statement of the problem, the angle in question is at C. Put in those angles. Right. The angle is at C. So we have highlighted C. To find any trig ratio of C, we may need to name the sides relative to it. The hypotenuse is the longest side, and it is opposite to the right angle. The hypotenuse is the longest side, opposite to the right angle. The side opposite to, facing, or on the other side of C is said to be the opposite of C, or to be opposite to C. So if it is opposite, like this, facing C, or on the other side of C, that side is called opposite. The side that is beside, alongside, or adjacent to C is said to be the adjacent, which is that one. And we need to know that what? The tan of C is opposite over adjacent. So what is the opposite? The opposite is 12 and the adjacent is 5. So tan of C is 12 over 5. And that is represented by what option? The correct answer is option C. If we were sharp, we could have taken note of the fact that tangent is exclusive of the hypotenuse. Only the other two sides are applicable. The other two sides are, apart from the hypotenuse, are 12 centimeters and 5 centimeters. Only one option has 12 and 5 together. We could have chosen it without considering which is to be divided by which. So here we have in the option 5, 13, 12, 13, and the other one 13, 5. So there's only one option that has 12 and 5 together. So we could have chosen that one quite quickly. And that is how in exercises like these multiple choice papers, we reduce the time, the amount of time spent answering a question. We realize that we need to include 12 and 5. We see 12 and 5 over here, we are done. We don't need to know if it is 12 divided by 5 or 5 divided by 12. Whenever the statement of the problem requires us to make that distinction, then we will have to do it. But in this particular case, it's not a complete necessity. We just manipulate multiple choice papers as we find necessary. Which of the following sets is equivalent to the set A, B, C, D? If two sets A and B are equivalent, then there exists a one-to-one correspondence between the elements of A and B. All this requires is that the two sets have the same number of elements. So NA must be equal to NB, and then we know that A is equivalent to B. Therefore, if we can identify the set in this particular case that has the same number of elements as the one in the statement of the problem, our work is done. So we look here. How many elements we have? 1, 2, 3, 4. How many we have down here? 1. Yes, this one. 1, 2, 3, 4. We are finished. So the correct answer is option C. The correct answer is option C. Set A is equivalent to set B. And if set A is equivalent to set B, we write. So this is how we express equivalence between sets. This kind of a arrow with half of the point going in one direction, and then we have another arrow with half of the arrow point in the other direction. Be careful to note that equivalence does not require that the elements of the two sets are the same, which is the requirement of equality. So it is equality that requires the elements of the two sets to be identical. But equivalence just requires that the number of elements are the same. Which of the following geometric figures always has 4 equal sides? All of the figures have 4 sides. They are all quadrilaterals. We therefore need to know the characteristics of quadrilaterals in order that we may choose the correct answer. So there is our first one, a kite. A kite is a quadrilateral that has 2 pairs of equal adjacent sides and is symmetrical only about one diagonal, and that one is coming from the Oxford Dictionary. So from the Oxford Dictionary we learned that what? A kite is a quadrilateral that has 2 pairs of equal adjacent sides. So we have these 2 sides are equal, they are adjacent to each other, and these 2 sides are equal, they are adjacent to each other. But it is only symmetrical about one diagonal. So this diagonal is here. And of course, we are sure that this one that we have up here, if we use this as a mirror line, is not the mirror image of the one that we have down here. So it is not symmetrical about this one, but it is symmetrical about this one, because the one that we have on this side is a mirror image of the one that we have on this side. It is symmetrical only about one diagonal. It is important to note also that the diagonals meet at right angles to each other. So in a kite, the diagonals are always at right angles to each other. The diagonals are unequal, and it is symmetrical about only one of them. This prevents all of the sides from being equal. So it is symmetrical about only one diagonal. And what else is said there? That the diagonals are also unequal in length. This will cause the sides not to be equal. So we'll have these two sides being equal and these two sides being equal. But if we look from here to here, those are not equal. So the sides, all of the sides of a kite are not equal. The rhombus is the one that is described as a flattened square. That means you have a square and you put some heavy weight on it and it starts to be squashed or to be pressed down. So while the square is being squashed, some of its characteristics are preserved. So some of the characteristics of the square are preserved when we squash it down to form a rhombus. The ones that are preserved are equality of all four sides. So we are sure now that the rhombus is the one with all sides equal. Some of the things that are preserved: equality of all four sides. The diagonals are perpendicular and diagonals bisect each other. So those characteristics of a square are preserved when we kinda squeeze it down in order to make a rhombus out of it. Some that are not preserved are, so some of the characteristics of the square that are not preserved when we squeeze it down are the equality of the vertices. The vertices are not equal. And the equality of the diagonals. The diagonals also are not equal. So they are not equal in length when we squeeze it down. And this is what it looks like. Right. So that is your first representation of a rhombus. All sides are equal, but this vertex, notice that this is kind of a big angle and this one is kind of a smaller angle. These vertices are not the same. If you put the diagonals in, they will cross at right angles, right, and they will actually bisect each other. Maybe you do not think that that one is flat enough. So you may not think that the rhombus that we have there, that one is flat enough. There's another one. That one is a little bit flatter. Do not worry about the proportions. It is not necessarily drawn to scale. The rhombus is the one with all sides equal. So we have a rhombus right there. And of course this one is flatter. And it might not appear that all four sides are equal. But this diagram is not necessarily drawn to scale. We're just giving you an example of what a rhombus is. And if you realize, we have this big angle right here. And of course, these are very small angles. So the vertices, the sides of the vertices are not preserved. So the rhombus is the one with all sides equal. The one defining characteristic of a trapezium is that two of its sides must be parallel. Two of the sides of the trapezium must be parallel. There we have trapezia. In America they say trapeziums. Right. We have the parallel sides right here. We have the parallel sides right here. And we have the parallel sides right here. As long as it has two parallel sides and it is a quadrilateral, it is. As a matter of fact, the two parallel sides is the only characteristic that a trapezium has, of course, apart from being a quadrilateral. So it is the only characteristic that it has. That is why we have a variety of shapes in which only two sides are parallel. So in this particular case, we have a variety of shapes in which only two sides are parallel, and that constitutes a trapezium. The parallelogram has two pairs of equal and parallel sides. At least it must have at least two pairs of parallel sides. This is why some of the other categories of quadrilaterals also pass as parallelograms. So we have other quadrilaterals that may be categorized in other ways or be given another set of names. Those may be classified as parallelograms because they also have two pairs of parallel sides. So we have a lot of different types of parallelogram. We have here a rectangle. A rectangle is a parallelogram. We have a square. A square is a parallelogram. We have a rhombus, that's also a parallelogram, and the typical parallelogram, no doubt, is a parallelogram. All of those are parallelograms, but a parallelogram is only capable of being one of them if the relevant characteristic applies. For example, a parallelogram with all sides equal may be classified as either a rhombus or a square. So the parallelogram with all sides equal is a rhombus or a square. A parallelogram with all vertices equal is a rectangle or a square. With all vertices equal, they are going to be equal to 90 degrees each. They may be classified as a square or a rectangle. So those are also parallelograms. Of all of the categories of quadrilaterals, the kite is probably the weirdest one. It does not mix quite easily, being classified as another or another being classified as a kite. So the kite does not mix quite easily. We do not have other popular quadrilaterals that are capable of being classified as a kite or a kite being able of being classified as one other. So it is the weirdest one. It is the furthest one out. A square is a rhombus, but a rhombus is not necessarily a square. So we have those two having some relationship. A square is a rectangle, but a rectangle is not necessarily a square. So we have more relationships there. A rectangle may be classified as a trapezium, but a trapezium is not necessarily a rectangle. And of course, if you do any calculation with trapezium, especially finding the area, you will find that as long as you can identify any quadrilateral with two parallel sides, as long as they have at least two parallel sides, any calculation that you make with trapezium, you will find that if you do the same with any other with two parallel sides, that they can be classified as trapezium. So if you want to use the area, use the method that you use to find the area of a trapezium. Apply it to a square, apply it to a rectangle, apply it to any parallelogram, apply that to a rhombus, and you realize that that will also give a correct answer. The volume of a cube which has edges of length 6 centimeters is, so we have a cube right there and each edge is of length 6 centimeters. What is its volume? A cube may be classified as a rectangular prism or cuboid. Its volume is given by volume is equal to length times width times height, and that is generally the formula that we use for a rectangular prism or a cuboid. The volume, that is. A cube is special because all of its edges are equal. Length is equal to width is equal to height. In this particular case, they are all equal to 6 centimeters. The volume therefore becomes length multiplied by width multiplied by height, and all of them are equal to 6. The volume is 6 multiplied by 6 multiplied by 6. So the volume is 216 centimeters cubed. The correct answer is option D. Let us take another go at it. We may also say that the other sides are equal to the length, since all of the edges are equal. So we remove the width and the height and we put L. All of them are L. All of them are equal. So the volume is equal to what then? Volume will become V is equal to L multiplied by L multiplied by L, which is L cubed. So all we need to do is cube 6. Find the cube of 6. 216. So that will be 216 centimeters cubed. In finding the volume of a cube on a speed, it is appropriate to just cube the length of one edge. If they say, what is the volume of a cube with length of edge is equal to 6, we just say 6 cubed or 4 cubed. And that is all there is to it. The following scores were obtained by 11 footballers in a goal shooting competition. And here we have them. The modal score is, of course, if we can identify the one that occurs the most times, no problem, we would have found the mode. As long as we can look at the list and identify the item that occurs the most times, then we would have found the mode. For this, we do not need to sort the list. However, sorting will ensure that we do not miss any item, causing the mode to be easily identified, as all equal values will be next to each other. So we will attempt to sort the list first. So sort the list. We may go from small to large or from large to small. Generally, we go from small to large. We generally sort from large to small when we are like giving the students a position in a particular test. We put the large one first because the largest will be the one associated with the smallest number. So the large one will be associated with 1 and so on. But in this particular case, and as is most often the case, we will sort by placing the smallest one first. Start with the single 2. There are 3 3s. Move on to the, which one? The next number in the list is 5 and we only have 1. We have 2 6s. And we almost miss one right here. 1 7. How many 8s? 2 8s. Any 9? No, only a single 11 is left. It goes right there. And we can see better that the mode is 3. It is already obvious which item occurs the most times. 3 occurs the most times. It occurs 3 times. It is the mode. So there we have the highlighted 3 times the 3 will occur, and that is the mode. The correct answer is option A. How can we miss that? What I am doing here is guaranteeing the correct answer under all possible hazardous conditions. It is quite possible that a candidate can look at the problem and identify the correct answer in a second, which is what you should be trained to do when you're answering multiple choice problems. We need to find f of 3 if f of x is equal to negative x squared minus 9. Right. In finding f of 3, we need to take the function f. There we have it. And what do we need to do? For the occurrence of x in f, we substitute the value of 3. We have f of x and we need f of 3. Nothing will change except that the x is replaced by 3 and the expression simplified. So where we see x, we put 3 and nothing else changes. Then we simplify. Right, I like this problem for more reasons than one. Simplify the result. We have what? F of 3 is equal to negative of 9 minus 9. Of course, 3 squared is equal to 9. No problem with that. And what do we have? When adding numbers that have the same sign, add the values and the answer will take the same sign as the numbers that we have added. So we need to combine these two. Some students may say negative and negative give positive, positive 18. But we say when adding numbers that have the same sign, combine the values and the answer will take the same sign as the numbers that we have added. Negative 9 minus 9 is actually negative 18. And the correct answer is option A. Good. We mentioned before about the square of a negative and the negative of a square. This one that we have here is the negative of a square. The negative of a square is always negative, but the square of a negative is always positive. So we take a negative, see, we have the negative sign here of x squared. This part will always turn out to be negative because when we square the number, whether positive or negative, the result will turn out to be positive. Then we have to apply the negative sign after. Because the square is always positive, after applying the negative sign, we are guaranteeing a negative value all the time. And that is why we have a negative 9 right here. So candidates must be able to make the distinction between the square of a negative and the negative of a square. A and B are sets such that NA is equal to 30 and NB is equal to 17. If B is a subset of A, then N A intersection B is equal to, so we need to find the number of elements in A intersection B given the set of circumstances that we have right there. We may put forward a simple argument that will cause us to end up with the answer in a short period of time. So what is the argument that we are putting forward? We are making use of the fact that B is a subset of A. B is contained in A. B is inside of A. Therefore, all of the elements that are in B are also in A. They are therefore all common to B and A. And what do we mean by A intersection B? The elements that are common to B and A are common to A and B, which is the same thing. So, all of the elements as we have here, B is inside of A. Therefore, all of the elements that are in B are also in A. They are therefore all common to B and A. The intersection of the two sets will contain all of the elements that are common to A and B. This will be all of the elements of B, since B is already inside of A. So we need all of the elements of B. And we know that all of the elements in B, we have 17 of them. The correct answer is option B, 17. Let us use a Venn diagram in assisting us to solve the problem. B is a subset of A, so we put the Venn diagram and we put B inside of A. What else? NB is 17, so we put 17 elements in B. NA is 30. But what? There are 30 elements in A. As we can see, the 17 elements of B are already in A. The number of elements in A only will be the rest of them. So we have a part here that we could put some elements, and we are going to do that. The elements in A only, and we know that NA is 30, and we have 17 of them in A. Of course, why? Because B is contained in A, and they are in B, so they are also in A. So the rest will be in A only, which is 30 minus 17 is equal to 13. Then we need to determine the number of elements in A intersection B. As we can see that B is inside of A with its 17 elements. Only 17 elements will be shared between the two sets. So the number of elements shared between the two sets, only the 17 that is inside of B will be shared between A and B. So NA intersection B is equal to 17. That's all there is to it. If the universal set U is equal to the set of 1, 2, 3, 4, 5, 6, and the set H is equal to the set 3, 4, 5, then H complement is equal to, we need to determine the set H complement. Let us construct a Venn diagram that represents the information. The set H will be contained in the universal set. Like that. The element of H that are in the universal set will be placed in the set H. Well, where else? So we will place the elements that we have in H in the set H. Although they belong to the universal set, H is inside of the universal set, and those elements are inside of H. There we have them. The remaining elements of U are placed inside of the Venn diagram, but not in the set H. So the other elements, 1, 2, and 6, they are placed inside of the Venn diagram, but not in the set H. The elements of H complement are the elements that are not in H, that is, those that are in the Venn diagram but outside of H. And we have them right there, 1, 2, 6. H complement is equal to the set that contains 1, 2, and 6. The correct answer is option D. It is quite easy to identify the elements of H that are not in the universal set. There we have the elements of H. The remaining elements of U are not inside the set H. They are the elements of H complement. So those that we have there highlighted in red, they are the ones that are in H complement. They are not inside of H. And H complement is equal to the set that contains 1, 2, and 6. The correct answer is option D.